this is another adenosine video that tumors like to use. So I'm going to be explaining and filling in some more gaps and adding some more details to adenosine. So quick recap, adenosine is something that tumors secrete, and it binds to A2A receptors on T cells. This causes an increase in CAMP, also decreases IF and Y. Basically, T cells use IFNY, or they secrete IFNY against tumors. So tumors suppress the IFNY. Tumors also suppress Granzyme B with adenosine. So Granzyme B is like an attack that T cells use on tumors to create apoptosis in tumors. So as a result of the adenosine being released by tumors, T cells become exhausted and lose killing ability. Now, this is where things get tricky when it comes to attacking tumors, is because tumors, when they are attacked by T cells, they actually release more adenosine. Now, what that ends up doing is that the adenosine, it changes macrophages towards an M2-like phenotype or suppressive state. What that ends up doing is that the macrophages in that M2-like state is that ends up supporting and protecting tumors. So that's what ends up happening if T cells dare attack the tumors. The problem with macrophages being in an M2 phenotype is that they are not in an M1 phenotype, because if they are, then the macrophage can clean up and engulf dying tumor cells that are actually secreting or releasing ATP that makes even more adenosine, that suppresses T cells even more, and of course ends up creating even more macrophage M2 phenotypes that support the tumors. So this is an ongoing cycle, or a self-reinforcing feedback loop that supports the tumors. Okay, hypoxia, low oxygen states, because of iron deficiency, actually helps tumors release more adenosine. So the goal is to reverse iron deficiency and to raise iron stores, because red blood cells, they need iron so that the red blood cells can deliver oxygen around the body to reduce hypoxia. Therefore, reducing adenosine, that is reducing T cell numbers and reducing a macrophage cleanup of dying tumor cells. Okay, so it's good to get vitamin C levels up, because vitamin C, it helps protect vitamin A from oxidative degradation, because vitamin A is important for parietal cells to create intrinsic factor for vitamin B12, because B12 cannot work without intrinsic factor. A great and rather simple food to include in the diet is carrots, because carrots, they provide Beta-Carotene, which is a provitamin A carotenoid. And these Beta-Carotene has effects on tight junction proteins in the stomach. And those proteins are occludin and claudin. Okay, so vitamin A in carrots, it has to be converted to retinoic acid first. And once that conversion is done, the tight junction proteins, occludin, claudin 1, claudin 4, and then zonula 1 are also affected. So the retinoic acid, once it's converted, upregulates tight junction gene transcription via RXR. So basically, a DNA is inside the chromatin. The chromatin has to be opened, and then the gene transcription factors that are supposed to upregulate or are responsible for tight junction proteins are enabled or go into the DNA if the chromatin is opened. So the chromatin has to be opened for that to work. So these tight junction proteins or retinoic acid also reduces NFKB. Uh, NFKB is the result of CD27, CD70 axis by tumors. So if you've seen my other videos on CD27, CD70 axis, you'll know what I'm talking about. Also, the tight junction proteins, they have to be tight and upregulated in order for vitamin C transporters to be able to transport vitamin C so that iron is in a bioavailable form, because vitamin C helps iron stay in a bioavailable form. Therefore, allowing red blood cells to reduce hypoxia around the body so that the hypoxia is not upregulating adenosine that is suppressing T cells and macrophages. So another reason to keep the tight junction proteins upregulated in the stomach for vitamin C transporter to work is because vitamin C also protects retinol from oxidative damage or degeneration, because retinol comes after beta-carotene from carrots. So the carrots uh, provide the B carotene or beta-carotene, then beta-carotene turns into retinol, and vitamin C protects the retinol from oxidative degeneration. Okay, the carotenoids in a vitamin or in a carrot are also fat soluble. So foods with healthy fats can help uh, the vitamin A conversion in carrots. Some of those would be olive oil, butter, egg yolks, also avocado. So those will help carotenoids in carrots because they are fat soluble. Now there is also a vitamin A conversion pathway, and that is called a BCMO1. So it's basically an enzyme, and there are foods that supports that vitamin A conversion. Uh, Also, iron is also required for that as well. So iron in red meat, liver, and oysters. Oysters are also very high in zinc. Also, beef and pumpkin seeds. Of course, the lysosome membrane cannot be peroxidized. Therefore, the iron will leak out and will not be able to be metabolized correctly. Therefore, without the iron, the BCMO1 enzyme won't function, and then the vitamin A will not be converted from beta carotene from carrots, and then the parietal cells will not get the vitamin A that it needs, and then vitamin B12 deficiency, because the parietal cells aren't making the intrinsic factor. So a great way to fix lysosomal membrane peroxidation leakage of iron is with a magnesium supplementation. Magnesium upregulates enzymes that or the repair enzymes for the lysosomal membrane if it needs repair. Okay, since the tight junction proteins, occludin and claudin, they have to be tight so that the iron is able to reduce the hypoxia that is creating too much adenosine that suppresses T cells and macrophages. The excessive zinc from oysters has to be avoided because too much zinc will close the chromatin, uh, and then the vitamin A or the beta carotene, or no, the retinoic acid, um, that is supposed to upregulate tight junction gene transcription will not be able to work, because if the chromatin is closed and shut, then the retinoic acid can't upregulate the tight gene transcription factors responsible for occludin and claudin in the gut if chromatin is closed, because retinoic acid will not be able to enter the DNA if the chromatin is shut. And then the occludin claudin type junction proteins will be loose or weak in the gut, leading to leaky gut, which is another topic for a different video. So that's it for the video. Share, subscribe if you want more future videos, because I have many more coming. Keep it locked on my channel. Share this video with anyone with health concerns, and I'll see you next time.